On October 28, 2025, a new aircraft developed by NASA and Lockheed Martin completed its unofficial maiden test flight over the California desert. The jet is called the X-59, part of NASA's Quiet Supersonic Technology or QSST program. The X-59 took off from Plant 42 in Palmdale, California, shortly after sunrise. It flew for about 1 hour at a subsonic speed of around 370 kilometers per hour and reached an altitude of approximately 12,000 feet. The flight was accompanied by a NASA chase plane and landed safely near NASA's Armstrong Flight Research Center. About 200 workers and family members were present to watch the event. The X-59 is designed to reduce the loud sonic boom that occurs when an aircraft breaks the sound barrier. It is built to demonstrate that it can fly faster than sound while producing only a soft sonic thump. This flight was conducted at subsonic speeds, but future tests will involve supersonic runs to evaluate the aircraft's noise reduction technology. The jet aims to make supersonic commercial travel over land possible again. Since the 1970s, passenger aircraft have been banned from flying supersonically over land due to the disruptive noise of sonic booms. NASA and Lockheed Martin's goal is to collect data that could help change those regulations. NASA began the X-59 program in 2018 and has invested over $518 million in its development. The project is being led by Lockheed Martin's Skunk Works division, known for designing advanced experimental aircraft. The aircraft is around 30 meters long and has a wingspan of about 9 meters. It is powered by a single General Electric F414 engine, the same type used in the F/A-18 Super Hornet fighter jet. Its unique shape and long pointed nose, more than 12 meters in length, are designed to control how shockwaves form and travel. By spreading the pressure changes more gradually, the aircraft avoids creating a single sharp sonic boom. The cockpit of the X-59 is positioned far back on the fuselage and it does not have a traditional forward-facing window. Instead, the pilot relies on a system called the External Vision System. The XVS uses cameras and sensors to display real-time imagery on a screen, allowing the pilot to see forward without a direct line of sight. When fully operational, the X-59 is expected to fly at Mach 1.4 or about 1,480 kilometers per hour at an altitude of around 55,000 feet. However, during its first test flight, it remained below the speed of sound as engineers gathered basic flight data such as control stability, air data performance, and system responses. The Lockheed Martin Skunk Works team will continue the aircraft's flight testing campaign in partnership with NASA. The next stages will include gradually increasing the altitude and speed leading up to the first supersonic flights. These tests will measure the aircraft's actual sound levels and verify that it produces the predicted low thump instead of a loud boom. NASA will later conduct community overflight studies where the X-59